Instead of they just sign up for as many days as they come and select the card and then they go and
We just
right before I started working on English or math.
I can't hear it.
I haven't turned it on. Now that I have turned it on, it's still not.
That it's true what they say about teachers, that those who can do, and those who can't teach. I decide to bite my tongue instead of his, and resist the urge to remind. Yes, that it's also true what they say about lawyers. Because we're eating, after all.
Okay, I'll just rewind the whole thing. This is kind of interesting, because there has been a whole bunch of email exchanges amongst the professors, and I have no idea why they were sharing videos, but this one was kind of interesting. This guy used to be a teacher, and he changed his occupation from teaching to being a slam poet. Is that the right term? So this is one piece that he did, with his, based on his experience as a teacher. And the earlier part of the context, was kind of cut off. So apparently he was, talking about, he's at a dinner with, some lawyer friends, and they have been all been bragging about, how much they make in terms of money. And they decided to make fun of him as a teacher and said, well, honestly, how much do you make? Basically that's the question. And then he just went on and talked about, what he actually makes, as a teacher. So we'll just kind of go over this a little bit because I personally think this is somewhat interesting.
He says the problem with teachers is, what's a kid going to learn from someone who decided his best option in life is to become a teacher? He reminds the other dinner guests that it's true what they say about teachers, that those who can do, and those who can't teach. I decide to bite my tongue instead of his, and resist the urge to remind the other dinner guests that it's also true what they say about lawyers. Because we're eating, after all, and this is polite conversation. I mean, you're a teacher, Taylor. Be honest. What do you make? And I wish he hadn't done that. Asked me to be honest, because you see, I have a policy about honesty and ass-kicking, which is, if you ask for it, then I have to let you have it. You want to know what I make? I make kids work harder than they ever thought they could. I can make a C+ feel like a Congressional Medal of Honor, and I can make an A- feel like a slap in the face. How dare you waste my time with anything less than your very best? You want to know what I make? I make kids sit through 40 minutes of study hall in absolute silence. No, you cannot work in groups. No, you can't ask a question, so put your hand down. Why won't I let you go to the bathroom? Because you're bored, and you don't really have to go, do you? You want to know what I make? I make parents tremble in fear when I call home at around dinner time. Hi, this is Mr. Molly. I'm going to have to call at a bad time. I just wanted to talk to you about something that your son did today. He said, leave the kid alone. I still cry sometimes, don't you? And it was the noblest act of courage that I have ever seen. I make parents see their children for who they are and who they can be. You want to know what I make? I make kids question. I make them criticize. I make them apologize and mean it. I make them write, and then I make them read. I make them spell definitely beautiful, definitely beautiful, definitely beautiful, over and over again until they will never misspell either one of those words again. I make them show all their work in math and then hide write it on their final drafts in English. I make them realize that if you got this, then you follow this. And if somebody tries to judge you based on what you make, you give them this. Let me break it down for you so you know what I say is true. I make a goddamn difference. Now what about you?
Well,
Can you scroll up in front of that video?
scroll up. Taylor Molly, that's his name. So according to his bio, you can actually look up his name. He's a teacher. Previously, he was a teacher, and then he became a slam poet, and has all these performances. Apparently, there's a following to his stuff. So that's kind of interesting. Now, I showed this just to make me look better. Because when you guys ask questions, I won't say put your hands down, because I'm not answering your question. Well, college is a little bit different, but nonetheless, I still have certain expectations. So, all right. So today we have the return value homework assignment due, which is about 7 minutes ago. Are there any questions about the return value homework assignment? No questions? Yep, go ahead.
I had a problem trying to close out that last line 13 return info.
Okay, we can take a look at that. So here's the homework assignment, and I'll go ahead and do it in the class. It's also kind of interesting, when I put all the video, online, the intention was, students from that class can watch, the content again, just in case they missed, a minute or two, or just, some minor concepts. I have a student from my Friday cisp300 class who has been watching my cisp310 lectures through the video. Now, 310 sounds like it's not so different from 300, but it's actually quite different, because in order to take 310, which is assembly language programming, someone has to pass the C programming class first. So he has been taking a class just by watching the video, by skipping the prerequisite of that class, and just doing it for fun, because he just thought, hey, this is kind of cool, I want to do that. So after he watched all the video, he wanted to take the test. Because he heard about how hard the test was for students who are in that class, okay, students with a proper prerequisite and whatnot. And he took the test, and today he visited me and said, well, Tech, that test was definitely not too easy. But remember, he did not actually take the test. He did not take the class. He skipped one class just to take that other class just to have fun. And he said, and I asked him, do you think you would have passed the test if passing grade is 37.5%? And he said, well, yeah, the question is, am I going to get an A or a B? So that was his only question. But it was kind of interesting how he was using the video recording of the class in order to take a class ahead of time. So by the time he actually takes that class, I think this student will not have any problems with that class. So I just thought that's kind of interesting, how you can utilize this resource, for that purpose. Okay, so let's go ahead and deal with this one. Now this one looks kind of nasty. We'll go ahead and just take a look at the solution and save it in today's folder. All right, let's go ahead and do it. Here's the trace. Okay. I guess we do need one, column for comments, but we won't need it until the very end. So I'll just hide it for the time being. We start with line number and the precondition. Do we have any global variables of any kind?
No.
Do we have any parameters or even local variables? None of those things. It's all about return values. Okay, so the precondition, there's nothing really to say, so we go to line 13. Line 13 is going to invoke S4, which is our quote-unquote subroutine. And we need to use return info because the subroutine returns a value. Every time you have a subroutine that returns a value, you have to use return info instead of return line number. Because not only do we have to know that we have to go back to line 13, we also have to know what else on line 13 do we have to do. Well, we just have to print out the return value of the invocation of S4. Okay. Once we set up the return info column, we can continue execution in S4, which is just line 11. Line 11 is a return statement. Okay, so we go execute the statement. But in order to figure out what I'm supposed to return, I have to first know what invoke S3 is going to return and what invoke S1 is going to return. I can only do one thing at a time. So what I'll do is I will say return info is line 11. I will deal with the first one first, okay, which is invoking S3. And after that, I would have to continue to invoke the second one. So let me just stop here and see if there are any questions at this point. Is that okay? Okay. The statement we want to execute is on line 11, which is ultimately is a return statement. But in order to do the return statement, we have to perform the addition first. But in order to perform the addition, we have to find out what the left-hand side and what the right-hand side, what are the values of the left-hand side and the right-hand side. But when we invoke subroutines, we can only invoke one subroutine at a time. And since we read from left to right for the most part, we invoke S3 first. When S3 returns, then we can go ahead and invoke S2. Any questions about this one at this point?
It doesn't matter which one we do first, right, when we're adding?
When you're adding, it doesn't matter. And in this case, for addition, the compiler does not enforce a particular order. So in this case, it can be left first or right first. But when you deal with disjunction or conjunction, because of the short-circuited evaluation thing, in that case, it has to be left to right. In this case, it is not usually enforced, which one goes first. So now we have to deal with invoke S3. And invoke S3 goes here, which is on line 8. So on line 8, we have a similar issue. This is not what I want to do. I want to drag this bar so that we can see just the column that we want to see. On line 8, it is almost the same thing. We have a return statement in the end. But before we can return, we have to add first. Before we can add, we have to figure out the left-hand side and the right-hand side of the add operator. So now we go ahead and specify the return info for this one. We have to go back to line 8 because this time I'm just dealing with invoking S1. When we come back, we have to invoke S2. Then we can perform the add operation. So that's how you deal with one invocation at a time. And then once we set up the return info, we'll go ahead and actually go into subroutine S1, which is on line 2. Line 2 doesn't really do much. It just executes the return statement, which replaces the question mark with a value that we are returning. In this case, it is 2. Then we go to line 3. Line 3 is the end of this subroutine, so we have to look up the return info. It tells us we have to continue execution on line 8. So here we are going to go back to line 8. But before we go back, we also have to say that this column is no longer useful anymore. So we go ahead and indicate that this is now deallocated. Look at font effects, do a strike through, like that. And now we're back to line 8. Now when we get back to line 8, am I right? Yes, when we get back to line 8 now looks like this, which means I have to invoke S2 at this point. Because when line 8 looks like this, I still cannot perform the addition operation because I don't know what the right-hand side is. I don't know the value of the right-hand side of the addition. So now it is time to invoke S2, which means I'm going to reallocate the same column E again, for the purpose of return info. And I still have to say we have more stuff to do on line 8. So now we say we have to return 2 plus whatever subroutine S2 is returning. Then we go into the subroutine, go to line 5. Line 5 says we want to return a value of 3. So we copy and paste the return info cell, change the question mark to a 3. Then we go to line 6. Line 6 is telling me that we have to we have to look up the return info column to tell us where to go back to. We are supposed to go back to line 8 after this, and then we can deallocate the return info cell, or the return info column. When we get back to line 8 looks like this. Do we have any more invocation to perform at this point? No, it's fully resolved. We are going to return a value of 5. But you cannot change 2 plus 3 to 5 at this point because we are not executing line 8 at this point. Okay, so it is not correct to say 2 plus 3 is 5 and change it to 5 at this point. The return statement does one thing. It just changes the question mark to the value that you're returning. It does not actually evaluate the expression at that point. So anyone who replaced 2 plus 3 to 5, will get some points deducted. Not a whole lot, but it is actually the incorrect thing to do, in a trace like this. Now we go back to line 8. When we execute line 8 this time, it is the same as, then we evaluate what is 2 plus 3. 2 plus 3 is 5. We are returning a value of 5, which means we have to take the return info cell, copy and paste it, change the question mark to a 5 like that, and then we are done with line 8. When we are done with line 8 here, we have to move on to line 9. Line 9 is the end of the subroutine, which means we have to remember where to go back to. I'm supposed to go back to line 11 here. And after I know where I'm supposed to go back to, and line 11 will look like this. Then it's time to deallocate this column. And then now we're back to line 11. When we get back to line 11 looks like this. Return 5 plus invoke S1. I still cannot perform the addition because the right-hand side of the addition is still unresolved. So now it is time to invoke the subroutine S1 again. Subroutine S1 is over here. It returns a value, which means I have to allocate the same column again for return info. This time I have to remind myself I'm supposed to go back to line 11. The first number on the left-hand side is already resolved. This time I'm resolving the right-hand side, so that's why that invocation is replaced by a single question mark. And then we are ready to go into subroutine S1, which is line 2. Line 2 returns a value of 2. We copy and paste, change the question mark to a 2, and once again, do not evaluate 5 plus 2 is 7. This is the wrong time to evaluate it. Okay. Then we go to line 3. Line 3 is the end of the subroutine. We remind ourselves that we have to go back to line 11, and line 11 now looks like this, which is return 5 plus 2. Return 5 plus 2 is return 7. At this point, then we say, we copy this and paste it, and change this question mark to a 7. And then we move on to line 12. On line 12, once again, we are at the end of a subroutine. We have to go back to line 13. And by the time we get to line 13, we now know exactly what we are supposed to print, which is the value of 7. Like that. And, of course, we use post to indicate that we are at the end of the trace. So let me just, take out this little bar here and show you what the whole thing looks like, because I think it is kind of important to see the shape of the trace. Are there any questions about this particular trace? Yep.
I don't think that I think I did the steps in the right order, but I didn't necessarily do it in the exact same syntax. Like, I didn't put return the question mark and then the invocation. I kind of used like a question mark and generalized it a little. Is that going to matter, or?
I have to read it to see exactly how you put it or how you represent the whole thing. The reason why I use this particular notation is because it does reflect what the program is actually doing internally. So it is not really just for the sake of homework assignment. It is actually for the sake of understanding when you are writing the same kind of code in C or any other programming language, what is actually being done. So it depends on whether your notation expresses the same concepts. If it does, it's fine. If it's not, then I have to look at it. Any other questions? There was another hand, I think. Yep. Okay. No questions? This is all good? Okay. I think we have seen something like this in the class, using, two invocations on the same line. Yep, go ahead.
Why didn't we have a comments column? Because before we did like the print.
Yeah, because,
value.
otherwise, there's nowhere to put the print 7, how do we
Okay.
know what we're supposed to do?
I just didn't see
It is kind of clear because by the time we get to this part here, it is already resolving the question mark to a 7. It's just that when we execute a print statement, we also have to see the effect of executing that statement. Yep.
We did do a similar one with the invocation, same line, but you had it within the
Right.
other invocation. I was using it as my example, and admittedly, I didn't do what we were supposed to do.
Well, I have to take a look and see okay, which part is deviating from this.
Well, on the
solution?
example, you had the invoke,
Yeah.
and then you had the other invoke in parentheses within that invocation.
Right. That's the
Uh,
one that we did in the class.
Right. It's add multi.
Mm-hmm.
And this one, you have two separate invocations separated.
Exactly. But it's the same reason, the same rationale. You basically have to resolve the invocations one at a time in order to resolve the actual final value. I'm just going to look at this note here and see if that part is covered in any way. Okay, invoking a return to a return. Okay, this is a simple return. And this is a invoke inside the invoke. And this one doesn't have that discussion. Let's take a look at the other one. Return the value from the subroutine. I guess we never talked about how to do the two invocations separated by addition. Okay. Hmm?
We did do something.
The add and multi, we have an X and Y
Right.
local variable or parameters, and it referred to those because the Y had to be resolved with
Right.
the first invocation before you could do the multi with the X.
Okay.
It's 322 files.
Let me see. So I covered, a lot of examples in the class. Just want to see if I have anything. Add and mult. This one has, an invocation inside an invocation. Okay, buy value, return value, and this one does not have that either. But let me take a look at the answers, the solutions, and see how people did with this homework assignment. It's the same principle. Basically, every time you encounter a place where, okay, I cannot continue unless I perform this subroutine call first,
Right.
then you have to perform that subroutine call, and wherever that subroutine call is, you have to replace it with a single question mark, and figure out what that question mark is supposed to be. Then you can move forward with whatever step is after that.
Right. The main difference that I did, because I was following the add and multi as my example as I went through it,
Mm-hmm.
is you showed that when you did the first invocation, you went ahead and crossed that out, and then you used the same line to continue the next invocation.
Which I also did this time. This one actually has about the same thing. If you look at the trace here, I reused the same column here.
I think you're
Right.
saying the multiple columns are confusing. Multiple columns for the return infos was,
Yeah, because with the example with the other one, I thought that we'd be crossing out the first red info before moving on to the next one and just carrying it.
You mean from row 10 to row 11?
No, from I think it was Maybe I just screwed up a step and that's what threw me off.
First invocation.
Yeah, the first invocation.
Okay, the first invocation is all the way up here. That's our first invocation to quote unquote the stub function.
Right.
Yeah,
And
so-
then I did the print question mark.
Uh-huh.
And then I went to line 11, and then
The question is, I think the big question is what do you put here? Because the original statement is return invoke S3 plus invoke S1.
right.
So what did you do? What did you put here?
I put the question mark, and I went from right to left when resolving it.
Which is fine. You can
so
you
I
can
did
change the
invoke
order.
S1 first.
Yeah, but that would be fine. If you invoke S1 first, then when you come back, then you invoke the other one. So your order will be slightly different. You basically
Right.
would expand it as the second step instead of the first step.
Right. My problem is because using the add and multi, I did less columns than you did.
You'll see.
It would, yeah.
Okay.
You'll see.
Okay, you'll see.
Well, there should
Okay.
be the same amount of columns
I
regardless
didn't.
of how you did it.
My problem was because of looking at that one, I didn't realize with further invocations, I had
Okay.
to start using the
Okay.
columns.
Well, I'll take a look at the homework assignment, and once again, the homework assignments really don't take up a lot of points, in your final grade. So it's a good thing. It's a good thing that we have, this discussion before the exam. By the way, next Tuesday we'll have a practice exam for the second examination, and then 1 week after next Tuesday we'll have the actual examination. When is spring break? I just want to make sure that 18th.
So it'll be right before the
So we'll still do it before spring break. I think that's good. I don't think we want to we want to do it right after spring break. That would not be good.
Is there a reason that we're not doing it on Thursday or?
We'll do it on Tuesday.
So we'll start
No,
the
I
new
mean-
stuff right before spring break.
Sorry?
So we'll start the new stuff right before spring break.
We'll start, we are almost done with all the scheduled, material. So we are moving into some stuff that, that is not actually on Moodle at this point. But if there are any questions about concepts that we have talked about already, it's a good time to do a lot of review at this point. Okay, any questions? I mean, we're already starting to talk about records. Yep,
I had a question about records. So,
yep, go ahead.
so we make our record, and that's like a cookie cutter,
Mm-hmm.
and we're actually, so it's almost like we're making a subroutine, but it's not a subroutine. It's like a
It's kind of the equivalence of a subroutine, but for organizing variables and values. So it's still a template, and the template does not do anything until you use it to stamp out cookies or variables. So in a way, it is kind of like a subroutine, because a subroutine is a template for code. Okay, whenever you invoke the subroutine, these things will happen. In this case, whenever you stamp out a cookie using this cookie cutter, all the cookies stamped from the same cookie cutter. They all have the same shape. They always have the same features, but they can have different values. In other words, you can have a cookie cutter to cut out one cookie which has chocolate chip, because you put chocolate chip into that cookie. You can use the next one to cut out cookies with raisins, because that's what you do. So the composition of the cookies can still be different, but they will have the same shape. And that's the whole purpose of record or structure or class. They are just different names of the same concept. Okay.
it looks like in this algorithm we defined.
Are you looking at the file that we did on Tuesday?
Yes.
Okay, let me open that up so
The,
that we can
course
look
date.
at that. Date compare. There we go.
Yeah.
Okay.
So it looks like at the very top we started, we defined our record, and then we made
Even
an
this part here?
object.
Okay, this part here from line 1 to line 5, this is the definition of the record, the type, the cookie cutter, the template. We are basically saying that the cookie cutter has a name of date, so that we can have multiple cookie cutters in a drawer, and we can identify the cookie cutters by its name. So that's why we have date with an uppercase D, because a lot of times, or it's a common practice to name types with an uppercase letter as the first letter, whereas with variables we use lowercase as the first letter. That's a common, I would say, naming convention across almost all programming languages. So VB programmers would do that, C programmers would do that, Java programmers would do the same thing. Yep.
Okay. So is the reason for these the records? We're defining what type of values can be accepted within that record. Is there a reason for that? I mean, do different programming languages have an accepted common value that they look for first, or do you understand what I'm saying?
Not exactly. Can you put it in a slightly different way?
Okay. For like here, up here we're putting integer.
Mm-hmm.
So it's going to accept only integer values.
Correct. Yes.
What is the main reason for that? Is that because if we normally put in something else and say we didn't classify it as an integer, it would be accepted as a different type of value?
That is correct, because it depends on the programming language that you're dealing with. When you're talking about C and Java and other programming languages, they are called strongly typed programming languages. In other words, every variable has to be typed. It has to have a type associated with it, so that the compiler will understand what to do when you refer to that variable or that particular field of a record.
Okay.
So that's why you have to have a type associated with it, when you define it, so that the compiler can know what to do, what can be done and what cannot be done with that value. Now, when you talk about the scripting language like PHP or Perl, it's a different story, because there's no such thing as a hard-coded type to something. You can look at 5, the value 5, and sometimes you can use it as an integer, sometimes you can use it as a string, and sometimes you can use it as a Boolean. So it can morph between all these different types depending on the context. But with C and C++ and Java, they're called strongly typed programming languages, which means the compiler would not try to interpret the thing in different ways for you. You have to specify exactly what it is supposed to be. And since most students in this class will move on to cisp300, I have to assume that the programming language is going to be strongly typed. So that's why we need to indicate the type of everything from now on. Yeah. But that's a good question. It's a good question because this part depends on the programming language. In Perl, there's no way you can do it. That you cannot even tell Perl that this thing is supposed to be an integer. There's no such thing in Perl, which is both a strength and also a weakness at the same time. Yep.
So basically in this we're saying that if we have any variable that's a date, it has to have 3 lines of code for the year, the month, and the day. All the
it has to have
values
3 what we call fields. Each one is called either you can call when we use the name record. Each individual item inside the record is called a field, F-I-E-L-D, which is a name borrowed from database programming. When you call it a struct, or when you call it a class, each one is called a property. But it's the same thing. It's basically a component inside the template. But each one has to have a name so that we can refer to that particular component when we need to only access a particular component. Okay, very good. Any other questions regarding this program, the first part of it? Because I think last time we finished this kind of in a rush as the last item in the class. Yep.
So notice that on line 7 and line 8 we have first day and last day defined. So those are our variables, right? Even
those are cookies, yes.
Okay.
Yeah, we have 2 cookies. One cookie is called first day, the second cookie is called last day. But both of those cookies are cut out using the cookie cutter called date.
Okay. To actually use those, do we have to do as we did and specify by values that are...
you mean down here?
Yeah.
Well, with records, any variable of the record type can be passed by value or by reference to a parameter that is also matching the same type. So as long as the type matches, you can pass it by parameter. In this case, we're passing, both by value to date. Okay. Any other questions about this example? No questions? Okay. If there are no questions, we'll go ahead and start with a new sample program. We're still talking about records, and then this time we'll deal with something that is related to your homework assignment. And I'll just go ahead and use complex numbers as an example again. And we'll go ahead and redefine the complex record type, which is start with an uppercase C, and it has an imaginary part, which is a number, and also has a real part, which is a number. When I use the word number, it means it is not just an integer, it can be any value. It can be a floating point number, not floating point, a real number. Because I don't want to use the word floating point number, because it implies how something is implemented, and I don't want to make that implication in this class. All right, so we'll just go ahead and make one subroutine. Okay, define sub, and I'll just call this one init complex. In the initialization of a complex number, that's all it does. If you will pass by reference into this number, C, which is the name of the parameter, and it has a record type or type of complex. So I'm passing in a complex number by reference. And what I'll do is I will say the imaginary part of this variable will get initialized to 0, and so will the real part of this number. And that's all that I'm going to do in this subroutine. And define stub, and we'll define a stub subroutine with a local variable x, which is a complex number, and then we'll go ahead and invoke init complex, and we use my local variable x to specify parameter c, and define sub, evoke stub.
Stub is a name for the subroutine?
Yeah, stub is just the name of a stub subroutine. The name, the word stub, in order to describe a subroutine, basically means that it's there, but not for any. It doesn't really have any logic to it. It's there only because I want to avoid, in this case, the use of global variables. Okay. All right. So let's go ahead and trace this program and see, what we can do with it, because at this point we have not seen how to pass a parameter by reference. So this is the first example of how we can do it, how we can pass a parameter by reference. We'll go ahead and use a new window to do it. I'm suspecting that most of you already have some kind of an idea of how to do this. Okay. Which is good. For the most part, in this class, if you feel that this class is boring, everything is just a chore, it's tedious, it's actually a good thing. Because it means that you understand the concepts, and it's just a matter of applying the concepts, just following the code, do it, mechanically, so that's why it is boring and it is tedious. It is when people think, well, I don't really quite know what to do with this line, then I start to worry, okay? So that's why, I said what I just said. There's nothing to talk about the precondition. We don't have any global variables. We start on line 14. Line 14 is going to invoke stub right away. So we'll say return line number. And in this case, the return line number is post because there are no additional lines following this. And then we get into the subroutine called stub. Line 11 does not really do anything. We start execution on line 12. Now, I forgot one thing. Nobody said anything, but I forgot one thing. I forgot to allocate for my local variable x. Now, this time, how many columns should I allocate for variable x? 2. Because x, what is x?
It's local.
X is a local variable, but what does it have?
Complex. Yes.
It's a complex. It has 2 components inside. So that's why, when we allocate for x, we are actually allocating for 2 things, because x dot I, which is the imaginary part of the complex number, is a number. It needs 1 column. And then x dot r, which is the real number part of the complex number, is going to take up another column. So that means in this case, column C and column D are both used to represent the local variable x. Are we doing okay so far? Because each number, each integer needs its own column. So in this case, we need 2 columns because x has 2 components. Each component needs its own column. So we'll go ahead and shrink it a little bit. Now, because x is a local variable, then all of its components are unknown, when they are created the first time. Then we can now go into the subroutine stub on line 12. Line 12 is going to invoke the other subroutine, which is called init complex. And now we have to set up, the return line number. Because it's not returning a value, we can just use return line number. And it has one additional column because it has one byref parameter. In this case, the byref parameter is just C, and C only needs one single column because it is a reference. In other words, parameter C of init complex is nothing more than a little slip of paper that has a call number to find the original item. And that's why it only takes up one column, because it is a single alias. It is not, we don't create one alias for each component of C. We create one single alias for the entire complex number that we know as local variable x in subroutine stub. So that's why, when you specify, parameter C, it is an alias of columns C to D in this case. Very good. And the return line number is just whatever is following the invocation, which is line 13. So now we can go into the subroutine, which is on line 7. Line 7 says I want to put a 0 into C.I. Well, let's take a look at what is C. C is a reference to column C to D. Column C to D is our local variable x, which is a complex number. Every complex number has an I component, so now we are just initializing the I component to a 0. Is that okay? I mean, it's a reapplication of the concept of passing by reference, but this time we have a little twist because we are not applying it to an array or a simple variable. This time we are applying it to a record. But it's the same concept. Any questions about this step here on line 7, when we execute line 7? No questions? Okay. Well, if this is what line 7 does, line 8 is really easy because it's just taking the other component of local variable x and initializing that to a 0 as well. Then we get to line 9. Line 9, in this case is fairly simple. We look up the return line number column. We go back to line 13. Then we have no use of these two columns anymore. And we just change those to represent that they are no longer in use. Then we move on to line 13. Line 13 is also the end of the other subroutine, and then we'll do the same thing. Just say that these are no longer needed. We have to go to post after that. And let me change the formatting so that we know that these are now deallocated. And that's the end of this sample program. Are we doing okay so far with this example?
A complex record can contain more than just two?
Well, the way I define it right now only has two components. Whatever number of components you define, that's the number of elements or the number of components that you will have to use throughout the entire program. In other words, you cannot add later on and say, oh, I also want to store this component in a record type. You cannot change that. Once you define the record type, it has to be like that. Yep.
So you can have like an array of records?
Yes, you can. You can have an array of records. You can also have a record that has an array as a component. Yes. We'll take a look at those.
They have to be the same type of record?
Yes, when you have an array. Yep. One of the restrictions of using an array is all the elements must be of the same type. So you can have an entire array of a record of a certain type, but you cannot mix in other things into the array. Okay. Any other questions about this example before we move on to more stuff related to records? No questions? Okay. So let me save this program first, because this one is going to be useful. This is directly related to your homework assignment. Call this records by ref, because we are passing records by reference in this case. Let me just show you what your homework assignment is for this week, so you can see how this example is related to your homework assignment. So this is your new homework assignment. It's just called records. And here is program. It looks kind of long, but it's really not too bad. We have a record type, okay, line 1 to line 4 defines a record type, I use it to represent an angle. To represent an angle using number of degrees and also the number of minutes. Okay, I did not really bother with seconds because once you know how to do this, dealing with seconds is actually pretty easy. The second subroutine is the core of this homework assignment. Subroutine init angle is taking in an angle record called x. The parameter has a name of x, but it is passed by reference, which means every time you change something in x, you're changing a column that does not belong to this subroutine, does not belong to init angle. The second parameter is called r, which is an angle specified in radians. Okay, which is you don't have to worry about the math part. As long as you know how to multiply and divide, you should be fine. So what we are doing is we're converting an angle measured in radians into degrees. There are 2 pi's in one 360 degree, which is 1 revolution. So the conversion into degrees is r divided by 2 pi, and then the whole thing times 360. Then we get a number of degrees within that angle. I use the floor function here because this number is not going to be an integer, and yet degree can only store integers, and that's why we take a floor of this number. The number of minutes, on the other hand, is basically the same angle, but this time we multiply it by 360 times 60 because there are 60 minutes in one single degree. And whatever this number turns out to be, we have to mod it with 60 because when you store an angle in degrees and minutes, the minute can only go from 0 to 59, and that's what the mod 60 is for. So in this case, you might want to use a calculator, because it is, it's just a little bit of a mess to do the calculation. The Windows calculator should be fine. And that's basically the core of the homework assignment. The other subroutine here is really just a stub function. All it does is it will invoke, it defines a local variable angle, which I call A. The first thing you want to do is to convert 1.785 radians. Oh, I specified the wrong variable name, didn't I? I changed that, that's why it got changed. So let's go ahead and save it first. Yep.
So with our by ref value, how do we deal with that without a local variable, at least in what?
We do. See,
Yeah.
that's local.
Oh, okay, so
It's the name of the second parameter that is wrong. This one should be R and not A.
I was actually referring to the previous subroutine now, 7.
In this one here?
Yeah.
What was the question?
So what exactly is by reference X referring to? I mean, what column would you end up using?
You cannot know just by looking at init angle because it depends on who is calling init angle and what it is passing as the parameter for X.
Okay.
So that's why you have to look at stub.
I see.
And look at line 13 specifically because I used the local variable A of stub to pass it on as parameter X of init angle.
Okay, so the second subroutine executes first, and that gives you the
Correct.
reference for the
Yep.
first subroutine.
Yep. But I do have to change this A to a R, because I used the name R inside init angle, and yet I used the wrong name A here. So that's because R stands for radian, and that's why I used the letter R. And then the second subroutine call is really quite simple. It invokes another subroutine called print angle. Print angle, on the other hand, it's only using passing by value. So you have to make a full copy of the angle record to the subroutine print angle, and then you print out both the degree and the minute in this particular subroutine. Okay. Are we doing okay so far? I mean, I can see some people may not be. Are you guys doing okay with this? Sort of? It's a combination of the concepts that we talked about today, which is passing by reference using a record, and also the concept that we talked about on Tuesday already, which is passing by value, using a record. So you have to combine, lectures of both classes in order to do this, one homework assignment. And let me just fix that note first, because I have to fix the name the reference to R is not correct. It is, it should be to A. Excuse me. A should be changed to R, and that's the change that I have to make. And now it is fixed. I just have to re-upload it later on. Well, let's do it now. Because if I say I would do it later, I would usually forget. Good. And that's it. I just fixed the source document, and now it is correct. Are there any questions about record types at this point? How to pass a record by value, how to pass a record by reference, and how to access individual components inside a record? Is that doing okay? Okay. So the next thing we want to take a look at, there are several things, we can go from here. But the first item that I think would be good is to show you how you can have a record inside the record. Okay, how you can nest a record inside the record. And we do it all the time. Remember what a record is? A record is a blank form. That's basically what it is. You go to, admission and, records and admission, and you ask for a form to add to a class. Someone will give you a blank form, and that's what it is. That's what the record is. It's a template for a form. When someone gives you a form to fill in, it is actually a variable already because you can write on it. It is a particular instance of a record type. So let's go ahead and write another program just to see what we can do with record types. Now, last time we have already done the date type. Okay, so we'll go ahead and do it again this time, but this time I'm not going to spell out year, month, and day of month, just so that it's easier to create the columns. So this is something that we have done already, is to define a type called date to represent exactly a date. How do I represent time? Time within a day. What do we need? We need an hour, a minute, and let's just say that we want to measure time down to seconds. Is that doing okay so far, what we have done? Okay. Now, this is all good, because one record type, can represent any particular day, and the other record type can represent any time within a day. But when you look at the timestamp of a file, does it just have the date, or does it just have the time, or does it have both? It has both. So what we need now is to say, okay, what about if we want to say, what if I want to represent a timestamp? Okay, when you want to represent a timestamp, you will need both the date and also the time. Now, how should I proceed at this point? In other words, I want to represent year, month, day of month, hour, minute, and second inside a timestamp record. I have two ways to go. One way to go, which is the obvious way, is just to copy and paste from the other two record types, and I can call it a day. Now, every time you copy and paste, you have to ask yourself, do I really have to copy and paste? Because copy and paste is considered a very dangerous idea. It's not just tedious, it's also dangerous. So in this case, we don't want to do copy and paste, because what we can do is inside timestamp here, I can say timestamp also has two components. The first component is about the date. Now this time I use lowercase date to represent the name of the component, and uppercase date represents the type, the record type of date. And the second component of a timestamp is the time, which in this case is lowercase t for time, and then uppercase T time for the record type that I want to refer to. Okay. let's take a look at this code at this point and make sure that we understand what it means. Does everybody understand what this means? It means that a particular component inside the record by itself doesn't have to be an integer, doesn't have to be a number. It can also be an entire structure or an entire record on its own. Now, this is a very powerful concept because it means that we can create larger and larger and larger record types by reusing, the smaller components.
So it's like it's a record within a record, like you've got multiple file folders almost?
Exactly. But in this case, we are looking at the structure of the variable. In other words, let's just make this fairly simple. Okay. In this case, I would use since I don't want to use global variables, I will still use a stub variable a stub subroutine in this case, and we just call x a timestamp, and we don't want to do anything really spectacular. We'll just say that I want to initialize the second of the timestamp to a 0. Okay. Now, how can I specify that? Let me say that again. What I want to do, what I have at this point is a local variable called x. The type of the local variable x is a timestamp. Now that means I should change this here because I forgot to say local. Okay, so just to be consistent with my own notation, this is a local variable called x. It has a type of timestamp. So that means x as a variable has two components. The first component that it has is called date, and the second component that it has is called time. But each component can break down also into 3 additional components. So that means if I want to initialize just the number of seconds that I want to specify with this timestamp, I have to say x dot, apostrophe s. The first thing we want to say is time, because the second belongs to the time component. And within the time component, we also have a second component, which I use the lowercase s character for. And this time, I can just initialize that to 0. Okay, so let's just take a look at this part here and make sure that we have no problem understanding the notation itself. Then we'll trace it, and then we can see how everything is actually represented using the columns. Are there any questions about the notation, the dot, the period notation? Let's take a look at this notation here. We first take a look at x. What is x? X, according to the declaration here, is a local variable, and it has a type of timestamp. According to the definition of timestamp, it has 2 components. The first component is called date. The second component is called time. It does not have a second component. Okay? The second component does not belong to x directly. It belongs to a subcomponent of x. When we say x dot time, then we are specifying the time component of x here. The time component of x by itself is also a record. It is of the record type time with an uppercase T. Then we can look up the definition of the record type time with the uppercase T and see that it has its own component called S. So that's how we can drill down. It's a subfolder kind of thing. Okay? Instead of looking at this x, the dot as a dot, look at it as a backslash in dots. That's basically what it is. Okay? Time is a subfolder of x, and S is a subfolder or file inside the folder called time. Yep.
So the local variable x is only storing the seconds?
Nope. It has 6 individual items. When we break it all the way down, it has 6 individual items. But you cannot get to the very small, the single individual item directly because the 3 components that we call year, month, and day of month, they combine into one single component that we call date. And the other 3, the hour, minute, and second, they combine and we call that time. So that's why you can only drill down one level at a time before you can get to the single number item. Okay. Question? Yep.
So if you have 2 timestamps or 2 records that are timestamps, like an X and Y, and all of the values for X are known, could you actually, with a single
assignment,
yes, assign them all?
Yes, you can. Because as long as the type of the right-hand side matches the type of the left-hand side, You can use a single assignment to copy an entire record to another record of the same type. If the type do not match, then you cannot do anything. That's a good question, because otherwise it would be kind of tedious to make a copy of something. Okay. So we'll go ahead and just invoke stub in this case and see what we will do with the columns, how everything is actually organized. And once again, this is a very useful concept because it basically specifies that you can do nesting when you define the record types. And that allows you to create fairly large and complex record types just by making small ones one step at a time, and you can make composites bigger and bigger and bigger in order to represent more and more stuff. One analogy you can use is when you fill in the form. Most of the time when they ask you for your date of birth, when you specify your year and the month and the day, they're on the same line inside the form. Okay, it's basically the same concept. You just have a smaller component inside a record type that sometimes can be treated as if it is one single item, and other times you have to look into individual components of that thing. Now here we take a look at the trace. The trace is going to be, for the most part, fairly simple. It is the organization of how we use the columns that is important. Nothing to say about the precondition. And this is line 19. We invoke the subroutine that we call stub, which is the only subroutine. The return line number is post. That's the easy part, which is not why we are here. And we have local variable x. Now, local variable x has two components, but each component is a composite. And together, x will take 6 columns. These 6 columns are combined, when they combine into one single variable x as a local variable. Then we take the first 3 columns, and we combine that and say that these 3 columns make up for the date component of x. We take up the next 3 components, and we say these 3 make up the time component of x.
Okay, so we don't even put timestamp, we just go straight into breaking it down?
Yes, that is correct. And that's because timestamp is the name of the cookie. When you're looking at columns, you're looking at, excuse me, I take it back. Timestamp is the name of the cookie cutter. But when you trace a program, you're no longer looking at cookie cutters, you're looking at cookies. And this is what we're looking is basically the cookie that we cut out using the cookie cutter called timestamp. Okay? But we do have to understand the structure of the whole thing. So when we look at date, it has 3 components. The first component has a name of y, and the next one is m, d, and then time itself has hour, minute, and second. And that's why x as a local variable starts with 6 different columns. And since it is a local variable, every single column is unknown. Okay, because when you create something like a local variable, you cannot make any assumptions of the values inside that particular variable, and that applies to every single column. The subroutine only has one thing to do, which is line 17. Line 17 is saying, we want to go to local variable x. Okay, we know local variable x is from column C to column H. But when you have an assignment statement with the right-hand side being just a number, you have to specify exactly which part of the structure is going to get the value 0.
You're on the wrong column.
Am I? Oh,
Yeah.
okay. Sorry. Oh, okay, you're right. Right there, line 17. Thank you. So on line 17, we have to figure out what exactly is this doing. Okay, it tells me that first of all, we want to access x. This is what the x is. But x has 2 components. So when we specify time, it narrows down to one of these 3 columns. But time itself, time of x, also has multiple columns. And then the third component, which is s of time, specifies a single column, which is column h in this case. That's the column that we are initializing to 0. And after that, we're done. We go to line 18. And line 18, you will look up the return line number to say that we have to continue execution at post. And then after that, all 7 columns will be deallocated. So we go to format, cells, and just indicate that all of these columns are gone at this point.
That's it.
Mm-hmm.
We're done.
We're done. All this example illustrates is how we can have a structure as a component inside another structure, how we can have a record as the type of a component inside another record. Do we have any questions about this? It's just adding the concept of nesting. No questions? Really? Okay, if there are no questions about this, we can move on and talk about how we can combine the concepts of arrays and records. They are basically what we call orthogonal concepts, which means one cannot take the place of the other. They are basically independent concepts, and yet they can combine and make things a lot more useful. So let me save this first. And how should I call this? Record in record. Go. So now we have another concept. Let's see, what should I do here? I will try to find the person in the class with the highest GPA. How about that? Okay. So I'll define a record type called student. And let's just say that in my record, for record keeping, all I want to do is to keep track of the ID of a student, which can be an integer. And I also want to keep track of the GPA of a student. In this case, it's going to be a number, because your GPA is not an integer, it is a real number. And record. So now I have a template, I have a cookie cutter that I can use to stamp out records, each one to represent the score of a particular student. Now obviously this is not the way a database is going to organize data internally, because most databases won't even keep track of the GPA of a student. It will recompute the GPA from the scores and the points from all the homework assignments, tests, and whatnot across all the classes. But just for the sake of this argument, we have something like this. And what we'll do is we'll have, this time I think we do need a global variable. So we'll go ahead and define, I won't use subroutine this time. So this time I'm just going to use the global global code without any subroutines, because that's not the point of this particular. Okay, why not just use a stub function? Okay, but this time I'll do a trick here. I'll do a trick because I will say I have a local variable, and I will call my local variable, well, I don't want to use the word class because class has a very specific meaning in object-oriented programming. So I'll say
Subject.
Subject, course. I don't know. Course is good. Okay. So I would say the course is, now this time is interesting because I can say this is an array of, let's say, 30 students. Okay? Now this is just my notation. You can do it any way you want. It's basically just saying that course itself is not a single student, it is an array of students. And let's make this not 30 students because that will take me a lot of columns. Let's just make it three students. It will still illustrate the point, but I don't need to make columns all the way out to the right hand side. And then what we'll do is we'll go ahead and invoke a subroutine that is not written here. Okay, so I will just invoke import grades. And I will say use course to pass by reference to a parameter called x. Okay, I'm not even going to give you the subroutine called import grades. I'll just pretend that we can import the grades into x, so we can get rid of that part, the uncertainty. Okay, so now we can try to find out what is the student ID of the person who has the highest GPA. So for that, we can go ahead and invoke another subroutine. Find highest GPA, and we'll pass course by reference to parameter x of the other subroutine, and define sub. And here I have to define the other subroutine, which is find highest GPA, which pass by reference the name x, which is an array of 3 student. This time it can be just an array of student. It doesn't have to be an array of 3 student. Local I as an integer, local m as an integer. Okay. All right. So now we have to specify the code. We have an array of student records, and I'm going to use I to control which student record I'm looking at, and I'm going to use m to remember the index of the student record that has the highest GPA. Okay, so it is kind of like find min index, except this time it is find max index instead of find min index, but in the context of an array. So it is going to be a little bit different compared to find min index. I will initialize m to be 0. In other words, I always make the assumption that the first student in the array has the highest GPA. Until I see someone with the highest GPA, I will change that. Yep.
Shouldn't say define sub find highest GPA?
Yep. Oh, define sub. Forgot the sub part. Okay. So now I'm ready to specify the loop. While I is less than bar x bar, do the following. I'm going to fix the indentation later. If a bracket, this is not array a, it is x. If x bracket m, now this is what we had before, and you guys can tell me how I should fix it. What we had before is directly comparing an element with another element. If this is smaller than the record that I'm looking at this point, then I should update m so it becomes I, and if I gets I plus 1, and while, and I'll just go ahead and print the ID of the student that has the highest GPA, so there'll be x bracket I, x bracket m dot GPA, and define sub. Now I go back and fix all the indentations. Up to here. Other one, which is our stub. So here. All right. Okay. Something is not right with this subroutine. I mean, with this code here to find the index of the largest element. Which part is not right? Well, let's go through it line by line and see if they make sense. M gets 0. Can an integer be initialized to 0?
Yes.
That's good. Can an integer be initialized to 1?
Yes.
Yeah. Can I compare an integer to an integer?
Yes.
Can I compare a record to a record?
Yes.
No. I cannot compare a record to a record. Now x is, what is x? X is an array of records. So that means an element of x is what? It's a record. Okay, because it's an array of records, so each element is a record. That means each element is a student record. Now, if we look up student record, we'll see that student record has 2 items. It has an ID, it also has a GPA. Now, if you say you're comparing a record to another record, how are you comparing? Are you comparing by the ID, or are you comparing by GPA? It is not defined. Okay, it is not predefined how you can compare a student record to another student record. So that means line 17 is troublesome because we cannot compare a record to a record. However, we can do this. We can say, take a look at the GPA of one record and compare that to the GPA of the other record. Now everything is okay. Why is everything okay this time? Because I can compare a number to a number, can't I? And that's how we fix this program. We have 5 minutes to go, and we'll go ahead and actually trace it. Okay. Invoke stub. It just looks long, it doesn't take that much time to execute. window. And trace this program. I'm hoping that most people can relate this program to programs that we have written before, particularly the one that finds the index of the smallest element, because the logic is about the same. Okay, this time we do have print, and also conditional statements, so we need comments, line number, and we start with the only line outside, which is line 24. Line 24 is invoking stub, and stub is just a stub function. It does define the local variable, so we have return line number here, being post, and we have to also allocate for the local variable that we call course. Course is an array of 3 students. Each student has 2 numbers or 2 items, so that means we have to allocate 6 columns altogether just to represent the array course. So we have 1, 2, 3, 4, 5, 6. I didn't highlight the columns before I change the size of the columns. So go ahead and do it again. All right. This is our course. It takes up 6 columns. The reason why it takes up 6 columns is it has 3 elements. Okay? Each element takes up 2 columns. Oops. The first 2 columns belongs to the first element, the second element, and the third element. I'm just using the square bracket because the course square bracket something. The first part is already redundant. That's why I don't use the other part. Each record or each item, each element in the array is a student, and each student has 2 components. Has ID and GPA, ID and GPA, ID and GPA. Are we doing okay so far? Okay. Now this part is very important because remember the entire purpose of this example is to illustrate how you can have an array of records, and this is how an array of records is actually represented internally to a program. Now that we know how to represent that, we can go to line 7. Line 7 is invoking a subroutine that is not defined here. Oh, we have to say that all of these are unknown first, right? Because they are a part of a local variable. But on line 7, I'm going to invoke a subroutine to import stuff.
You're in the wrong column yet, though.
Oh, that's right. I keep doing this time. Line 7 is going to initialize all of these things, so I would end up with actual values. So I'm just picking some random numbers here. Somebody gets a 0 as GPA, bad, very bad. And this one has got, let's see, I guess someone wants to transfer to Berkeley, so it has a 4.0 GPA. Okay. Well, it's not enough to transfer to Berkeley, but it's a good start. If you try to transfer to the engineering program of Berkeley, I think it's going to be very competitive. Going from a high school, a GPA of 4.0 is definitely not enough. Coming from a community college, maybe. Yep, go ahead. Oh, I thought you had a point. Okay. And now we go ahead and execute line 8. Line 8, well, we're running out of time, and I don't want to really push this. We can continue this on Tuesday, okay? And you guys can probably try to figure it out. Okay, this is what I'll do. I'm going to make this a ungraded homework assignment. So for those of you who want to, go ahead and try to do it, go ahead and try to do it. This is already set up already. The rest of it should be fairly straightforward, okay? So go ahead and give it a try, and then on Tuesday we'll have our practice exam, and also to answer this question, I will give you the entire full trace on next Tuesday.
Thanks, Dick.
Have a nice weekend.
How would Davis be? Is it variable to Berkeley, or do you run the same level?